Hi everyone, this is Group 10. I'm Yu Jiehua. This is Wenhao Li. Hello. This is Vanina Zhang.
Hello.
And this is Yuhao Wang.
Hello.
Our project is about the capacity monitoring algorithm using YOLO and DEEPSORT.
In today's COVID environment, most indoor spaces have limited capacity in order to prevent the spread of the virus. However, it is unrealistic to have humans to count people all the time. Thus, we investigated on the possibility of using cameras to monitor the number of people in real time with the help of machine learning techniques.
This is one of our demonstration videos. We predefine the boundary line. The red circle goes down and the green circle goes up. This one is taken just outside of our data building. The model has tracked every person in that frame and counted the number of people that cross the line. If the camera is pointed at entry of an indoor environment, it will be able to keep track of the number of people in that indoor space. Using a collapsed CPU, we are able to achieve a minimum of 10 frames per second, even when the frames are very crowded. This one uses an input video of 5 frames per second, and as you can see, it's still pretty good. Here are some more testing videos.
Two data sets of class person was used to train YOLO V4. Additionally, we have to write a conversion script to match the dataset annotation format to YOLO's requirements. This is the YOLO V4 general architectures. Its output for each detection are the bounding box and its confidence. They are then fed into DEEPSORT, which perform tracking using common filters. With DEEPSORT's ID bounding box output, we calculate people's distance to the boundary line. The total number of people simply decrements or increments depending on the crossing directions.
Since it will be difficult to quantitatively measure DEEPSORT's performance, it was much more efficient to optimize YOLO V4's performance first, before feeding DEEPSORT. By tuning two datasets' hyperparameters separately, we obtained the best model for each of them, evaluated using mean average precision of 0.5. Then we qualitatively compared their performances using pedestrian test videos in order to get evaluations that are unbiased from their own validation set. The best one is then converted into TensorFlow model and fed into DEEPSORT. By tuning and testing, we obtained our final set of DEEPSORT parameters in combination with our best YOLO V4 model.
One of the valuable things that we learned is that you should choose a dataset that is as close to what your project needs as possible. For example, in our case, we used one dataset with images that contain a variety of kinds of compositions, include different camera distances, different points of view, various people density, and different body parts under occlusion. We use another dataset of almost all crowds, almost all standing people. It turned out the model trained using the second dataset performs better on our pedestrian testing video, which does consist of crowds of people and almost all standing. See, if we were to do this project again, we would have gone straight to this dataset, or even find more suitable datasets consists only pedestrians. Also, when comparing datasets, we found that it is not quite fair to judge models' performances based on their MAP when you are using multiple datasets. Like here, these comes from two models that are trained by our two datasets. They have similar performances, but when evaluated by their own test sets, there is a huge difference.
Be careful with the things that might come up along the way. For example, the training process may take longer than you expect. The annotation format from online may not match the format that your model requires. so actual work may be needed.
There are some future works that can be done to improve our project. First, the hyperparameters in YOLO v4 can be tuned furthermore. Second, we can make it more user-friendly and easier to set up. And last but not least, this concept can be transferred to other projects like parking lot vehicle counting. Thank you so much for watching. See you. Bye-bye.